Hello everyone, today we are going to learn about the metric system, SI units, and English system of measurements. So before we move forward, I would like to introduce your presenter for today. My name is Micah Manansala from BS Ed 3A, specializing in sciences. I hope that you will learn something from this presentation. So let's start. So let's begin with the definition of measurements. What does measurement means? So in this slide it says that measurements is to measure something, to give a number to some property of the thing. So measurement or measuring that something puts the amount or into numbers. If you look into your surrounding, you can see that there are a lot of items you can measure, but aren't you curious how does one system of measurement measures all the stuff? So now let's talk about measurements' important role in our daily life. They are useful to do basic tasks such as taking a child's temperature with a thermometer or make time estimations, measure out medicine, and find weights, areas, and volumes of different materials or substances. So without the ability to measure, it would be difficult for who? For scientists to conduct experiments or form theories. And not only is measurement important in science and the chemical industry, it is also essential in farming, engineering, construction, manufacturing, commerce, and numerous other occupations. So let's begin with the first measurement, which is the metric system. It is a decimal-based system and all of the units are based on the power of 10. In the example below, if you have 3,000 meters, it will be equivalent in 3 kilometers. Why? Because you have to move the decimal to the left or right depending on if you're getting bigger or you're getting smaller. So this is the reason why we have to move decimals from left to right or right to left. The metric system is a system of measurement that uses the meter, liter, and gram as base units of length for distance, capacity for volume, and weight for mass respectively. And this figure below are the units used to measure smaller or larger quantities. We use derived units from the metric units, the kilo, hecto, deca, base unit, deci, centi, and milli. In this slide, the given figure shows the arrangement of the metric units, which are smaller or bigger than the base unit. The units to the right of the base unit are smaller than the base unit. As we move to the right, each unit is 10 times smaller or 1/10 of the unit to its left. So a deci means 1/10 of the base unit, centi is 1/10 of deci or 100 of the base unit, milli is 1/10 of centi or 1,000 of the base unit, and deca means 10 times of the base unit. Hecto is 10 times of deca or 100 times of the base unit, and lastly is the kilo, which is 10 times of hecto or 1,000 times of the base unit. So this is the picture representation for length in which its base unit is meter. Well, this is the capacity for volume and its base unit is liter. Examples include measuring the amount of juice in a juice can or amount of water in a water tank. And lastly is the weight for mass and its base unit is gram. Its examples include measuring weight of fruits or our own body weight. So to remember the prefixes of the metric system, there is a mnemonic like King Henry died by drinking chocolate milk. We also have the time and its unit is second and symbol is small letter s, and temperature for Celsius and its symbol is degrees Celsius. And for the SI units of measurement, it's an abbreviation of the French word Système International. It's an international decimal system of weights and measures derived and extending the metric system of units. It was adopted by the 11th General Conference on Weights and Measure in 1960. It has made up of 7 base units which are used for defining 22 derived units. In the table here are the 7 base units of SI unit of measurements. Number 1 is the length for the meter, mass for the kilogram, time for second, electric current for ampere, thermodynamic or temperature for Kelvin, amount of substance per mole, and luminous intensity for candela. While the SI derived units are units that are unlimited and can be derived to a new formula by different operations of the base units. In here are the examples of the derived units that are commonly used: the force or the weight, frequency, electric charge, electric potential or the voltage, capacitance, resistance, and many more. And for the second system of measurement, which is the English system, it is defined as the measurement system used in many countries, including the United States, using the feet, pounds, and seconds. While the metric system is easy to use, the English system is hard because it uses body weights and measures. So from the first problem of mass, we have to convert 83 hectograms to grams. So I'll be showing to you how to use the mnemonics King Henry died by drinking chocolate milk. So we are here at the hectogram and we have to go to the base unit, which consists of the gram, meters, and liters. And rewrite the given 83. Since it's a whole number, the decimal point will be on the right side of the number 3. So we also have to move the decimal point 2 times. And the result is 8,300 grams. And the second problem is convert 8,300 grams to kilograms. So this will be for the SI unit. Rewrite 8,300 grams below, and remember that 1 kilogram is equals to 1,000 grams. So let's multiply it to our given number. So 8,300 grams times 1 kilogram over 1,000 grams is equals to 8.3 kilograms. And remember to always cancel the unit. So the third sample problem is to convert 8.3 kilograms to pounds. So this is from SI unit to English unit. Rewrite the given number, which is 8.3 kilograms. And remember that 1 kilogram is equals to 2.20 pounds. So 8.3 kilogram times 2.20 pounds over 1 kilogram. Cancel the same unit. Our result would be 18.26 pounds. So for the volume, we have to convert 650 ml to liter. We will be using mnemonics again. And from here, we have ml, and we have to go to the base unit, which is the liter. So rewrite the given below, which is the 650 ml, and we have to move the decimal from right to left. So the result is 0.65 liters. For the second problem in volume, we have to convert 0.65 liters to meter cube, which is an SI unit. So rewrite 0.65 liters, and remember that 1 liter is equals to 0.001 cubic meter. So we multiply it to 0.65 liters times 0.001 meter cube over 1 liter. Then cancel the same unit to get the cubic meter. So the result is 6.5 times 10 raised to negative 4 cubic meter. For the last problem in volume, we have to convert 6.5 cubic meter to quarts. So rewrite 6.5 cubic meter, and remember that 1 cubic meter is equals to 10
56.69 quarts. So multiply it. 6.5 times 1056.69 quarts over 1 meter cube. Then cancel the unit. So why do we have to cancel the unit? To get the quarts. And of course, to cancel them, one must be in denominator and one must be in numerator. So if we multiply 6.5 to 1056.69, we will get 0.69 quarts. So another problem in density. The first problem is calculate the density in gram per centimeter cube of a ruby which has a volume of 1.6 centimeter cube and a mass of 6.7 grams. So we have to jot down the mass, which is 6.7 gram, and the volume is 1.6 centimeter cube. So the formula for density is P is equals to M over V, which is mass over volume. So we just have to substitute it. 6.7 grams over 1.6 centimeter cube is equals to 4.19 grams per centimeter cube. So for the second example in density, we have to convert 4.19 gram per centimeter cube to kilogram per meter cube. So write down the given 4.19 gram per cubic centimeter, and remember that 1 gram is equals to 0.001 kilogram, and 1 cubic centimeter is equals to 1 million cubic meter. So we multiply it to 4.19 times 0.001 kilogram over 1 gram times 1 million cubic centimeter over 1 cubic meter. So we cancel the unit and the result is 4.190 kilogram per cubic meter. Convert 4.190 kilogram per meter cube to pounds per gallon. Rewrite 4.190 kilogram per cubic meter, and remember that 1 kilogram is equals to 220 pounds and 1 meter cube is equals to 264.17 gallon. So 4.190 kilogram per cubic meter times 2.20 pounds over 1 kilogram times 1 cubic meter over 264.17 gallons. Cancel the units, is equals to 34.89 pounds per gallon. And the second to the last computation is the temperature. So for the example, we have to convert 125 degree Fahrenheit to degrees Celsius. So the formula for looking into Celsius is equals to Fahrenheit minus 32 times 5 over 9. So we begin by writing down the given 125 minus 32 is equals to 93 times 5 is equals to 465, divide 9, and the result is 51.67 degrees Celsius. The second example is to convert 51.67 degrees Celsius into Kelvin. So this is into SI unit. So the formula for Kelvin is Celsius plus 273.15. So write down the given 51.67 degrees Celsius plus 273.15 is equals to 324.82 Kelvin. And the last sample problem in temperature is to convert 324.82 Kelvin to degree Fahrenheit. The formula for Fahrenheit is 1.8 times Kelvin minus 273 plus 32. have to substitute the Kelvin. Write down the formula 1.8 times 324.82 minus 273 plus 32, and the result is 125.28 degree Fahrenheit. And the last one is the concentration. So the concentration of a solution is a measure of the amount of solute that has been dissolved in a given amount of solvent or solution. So for the first sample problem in concentration, we have a 780 ppm or parts per million. So in every 1 gram per liter, there is 1000 ppm, and 1 mole per liter is equals to 35,500 ppm, and 1.60 pound per cubic foot is equals to 1 ppm. The metric unit, we have 780 ppm times 1 gram per liter over 1000 ppm. Cancel the unit is equals to 0.78 grams per liter. So for the SI unit, 780 ppm times 1 mole per liter over 35,500 ppm. Cancel the unit is equals to 0.022 mole per liter. And for the last one, in English units, 780 ppm times the 1.60 pound per cubic foot over 1 ppm is equals to 1249.44 pound per cubic foot. For the second example in concentration, so we have the 780 again, but the unit is in ppb or parts per billion. So for every 1 million ppb, it is equal to 1 gram per liter. For every 1 ppb, there is 0.001 ppm, and 1601846.36974 ppb is equals to 1 pound per cubic foot. The first example is in metric unit. 780 ppb times 1 gram per liter over 1 million ppb. Cancel the unit is equals to 7.8 times 10 raised to negative 4 grams per liter. The second one is 780 ppb times 0.001 ppm over 1 ppb. Cancel the unit times 1 mole per liter over 35,500 ppm is equals to 2.2 times 10 raised to negative 5 mole per liter. And the last one is 780 ppb times 1 pound per cubic foot over 1601846.36974 ppb. Cancel the unit is equals to 4.87 times 10 raised to negative 8 pound per cubic foot in English unit. So that's all for today, and thank you for listening. I hope you learned something from this video. Thank you.